Hey guys, couple little different things I wanted to go over here with some of the worksheets that we've got. And on page 8 to 13, basically pages 8 to 13, um, are practice for writing these nuclear equations. And I just want to cover a couple of little things along the way on these reactions. On page 8 and 13, you should be able to basically be able to do these. This is actually not a problem. But what I want to make sure that you know is that once in a while you may see. So if you look at on this page, if we kind of go down a little bit to the second, so basically page 8 is going to be natural decay equations. You should be able to fill these out, based on filling out the particle. Okay. The next page is artificial transmutation, where you have two on the same side, but basically you have the same idea. I just wanted to show you one thing you may have not have seen before, and that's something like that, where you have 3 times a neutron. That simply means that you're going neutron plus neutron plus neutron. Okay, so instead of writing long equations of this, they simply put a coefficient in front. So that 3 stands for the 1 and for the 0. So when you're adding everything up, just make sure you keep that in mind along the way. All right, so that's page 8 and 9. Okay, and on page 10, I just wanted to just go over this a little bit. Sometimes when things decay, they do something called a decay series, where they decay in steps. Okay, and I just wanted to just review this with you quickly. So in this case, this is a map on how uranium-235 would decay to eventually decay down to a lower mass element. And it does this by doing a series of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps. And you'll see this. So what does this all mean? Basically, you're going to take uranium-235, okay, and then the first step is going to be called an alpha decay. The second one would be a beta decay, and the third one would be another alpha decay. So basically, they're showing you what this element's going to do as it decays in steps. And each step represents a different equation. So for example, if uranium-235 was going to do an alpha decay, the first equation you would write would be 235 arrow, right, because it's decaying, and then you put your alpha particle, okay, and then you'd fill in your missing nucleus. So again, top numbers have to be the same, top numbers have to add to 235, bottom numbers have to add to 92. So down here would be a 90, that would be thorium in the periodic table, and what number plus 4 would be 235 would be 231. Okay, so that takes care of step 1. All right, then you would go and do a beta particle. Now, please remember that anything on here is going to be beta minus, okay? Beta minus, again, is this electron. So just make sure you know that going for this whole map, okay? And now we'll write a second reaction. So a second reaction would be this one. So we're going to take the thorium-231, and we're going to start with another beta. We're going to start another reaction using that one. And again, we're going to emit a beta particle this time. All right? And so what number minus 1 is 90? We would say 91. And that would be PA. And then 231 equals 0 plus 231. All right? So again, you can see, so that would be the second one. And then you go on and so on. Now, what's with this detour? Well, you could either go this way or you could go that way. So it really doesn't matter which way you go. So if you take the high road, then this would be 4, this would be 5, and then this would be 6, 7, and 8, and so on. And then you can also go down here. So you can make this 9, 10, and 11 if you want, or you could take the high road. But eventually what you want to end up doing is seeing, after you do these 11 steps, do you end up at lead 207? And so that's your prize. So you get to see if you do this. So that's what I'd like you to do on this page. So I just wanted to be able to explain that to you. All right. If we go to the next pages, these 2 pages, again, are practice pages. And the last page I wanted to get to really is this one, which is making the transuranium elements. Again, transuranium elements are any elements greater than uranium, 92, right? So you start with 93, okay, and then we go up to, you can go all the way up to, 103. The reason I want to do this, I just want to kind of show you how you would do these because they could be a little tricky here. So if you take a look at here, 99, we'll do this one together. We have this situation where you have, how you make these elements. So basically on the right side, we're going to have to fill in a couple of things. We'll see down here would be element number 99, okay? So what we want to do is we want to find the missing element here. So we want to find out what we have at the top here. So 253 plus the 0, you would have a total of 253 at the top. That's supposed to be a 5. Sorry, guys. So 253 is at the top, okay? So there has to be a 253 on the other side, okay? A total of 253 on this side. However, you have 15 neutrons. Now, the way you read this is that 15 times 1 is really 15, right? So, again, 15 plus some other number must be 253. So you're going to have 238 at the top here, right? So the 238 plus the 15 will make the 253, okay? And the 15 0 at the bottom gives you nothing. So right now I have nothing at the bottom plus some other number. Okay, now I have a 99 here, and what this is on the top is that's plus 0, right? Because nothing at the top, but there's a minus 7 at the bottom. So 99 minus 7 is going to be 92. So that has to be 92 here, and that would be uranium, right? So that's how you do, so this would be the answer, okay? And this would end up being Einsteinium would be your number 99, okay? So that's how you do up through page 13. I just wanted to just show you how you go along the way, okay? And again, if we look through our other pages, that would take us up through 13. Through basically up through 13. So I just want to show you that how we work that way.